Okay, this next one is a little bit more challenging. The sum of the squares. We're going to have x and x plus 1 as our consecutive integers, but then we're going to sum their squares. I need to put parentheses around the x plus 1, and sum means add them. This is going to be 9 less than, so I'm going to be subtracting 9 from 10 times their sum. And sum means add. Add the x and the x plus 1 together. Wow. Okay, on the left we've got x squared plus, and this becomes a FOIL problem, x plus 1 times itself. On the right, inside the parentheses, I'm going to combine like terms to write that as 2x plus 1. On the left, I'm going to do some foiling here. The first term will be x squared, outer will be x, inner will be x, and last will be plus 1. On the right, we're going to do some distribution to get 20x plus 10, then minus the 9. I'm going to combine like terms on both the left and the right. This is going to then give us 2x squared plus 2x plus 1 equals 20x plus 1. This is a quadratic equation and needs to be set equal to 0. So I'm going to subtract a 20x off of each side, as well as subtract a 1 off of each side. And on the left side, we're going to have 2x squared minus 18x. The constants cancel, and that is equal to 0. We can now factor out a greatest common factor of 2x, leaving x minus 9 equals 0. And we get x equals 0 or x equals 9. Those are not the solutions. We're looking for consecutive integers, so we're going to have an x plus 1 giving us 0 and 1 as our first solution set, and another x plus 1 giving us 9 and 10 as our second solution set. Now, I think it's worth our time checking our answer. The sum of the squares. On the left, we're talking about 0 squared plus 1 squared. Move that up. Is 9 less than 10 times their sum. 10 times their sum. That's 10 times 0 plus 1, which is 1. 9 less than that. I get 0 plus 1, that's 1, equals 10 minus 9. 1 equals 1. Those work. Now on the other side of the equation, the sum of the squares. 9 squared plus 10 squared. 9, that's 81 plus 100, which is 181. Is that 9 less than 10 times their sum? 10 times the sum, that's 10 times 19. 9 less than that. 190 minus 9, which is 181. Phew, they check. Not that we wanted to check them, but I think it's good that we do this every once in a while. Okay, here we go. The product of two consecutive odd integers. Consecutive odd integers can be represented by x and x plus 2. Product means we're going to multiply them. Is 63. This is much nicer than the last problem. Distributing on the left, we get x squared plus 2x. This is quadratic, so we're going to have to set it equal to 0, so I'm going to subtract 63 from each side. This will now be factorable into x plus 9 times x minus 7. And we get two solutions for x of negative 9 or positive 7, which are not consecutive because one's negative, one's positive. We're looking for an x plus 2 to go with each of them. So the first solution set will be negative 9 and negative 7, and the second solution set will be 7 and 9. And there we have it. There's nothing in the problem that says negatives aren't allowed or fractions aren't allowed, or that we have to have these or can't have these, so those are the two solutions.